Today we'll try to design a collection tank in a sewage treatment plant. We'll use this as an example and a case study. Let's try to design a collection tank for a school. A school that runs between 9 a.m. to 4:30 p.m. How should we design a collection tank? And why does this matter at all? Most sewage treatment plants are designed as steady state flow. This means there is a steady flow of water that is put into the aeration tank. But it is not the case when it comes to the water flowing into the collection tank. In the collection tank, the water comes from the building, from a school. The water enters into the collection tank when the students use the toilets, wash their hands, eat their food, and maybe when they're having intervals between classes. Typically, a school functions between 7 to 8 hours in a day, and they also have weekend holidays, as opposed to a mall which has high inflows or influx of people. During the weekends, school almost has no influx of students during weekends. One significant factor in a school is that the peaks are very high because the students are rushing to their toilets and the urinals during the time when they are free from class. This has to be also considered in designing the sewage treatment plant collection tank. Let's see how the behavior pattern in a school typically is. Between 8:30 and 9:30 a.m., students come in. They may use the toilet. Some of them even go and play with the taps. They are smaller kids. Between 10:30 to 10:45 a.m., there could be a short break. Then between 12:30 and 1:30, there's a lunch break. And there's a small break in between as well. And probably at 5 o'clock, there's almost no flow coming to the sewage treatment plant because all the students have left the school. We've already seen a chapter on peak flows. Now let's also see what's the peak factor to be considered for this school. In this school, I would say a safe peak factor would be somewhere between 4 and 6 or even 8 if the school is running with just a lot of children in a very short span of time. To be on a safe scale, let's say between 4 and 6 should be the peak factor for a school. Assuming 1,000 student school, the per capita consumption of water is 45 liters, which adds up to 45 cubic meter per day. The school running time is 7.5 hours. And the lunch break is also there. So we are splitting this into peak flows. The peak flow in the school would be 6 meter cube per hour, and during lunchtime will be about 12 meter cube per hour. So an average peak factor, considering the school running for 7.5 hours, a 6.4 is the most logical peak factor to be considered in the design of the collection tank. If this is not considered, what can happen? The collection tank may overflow. There could be a shock in the reactor because the usage pattern is different, and the values of DOD, CODs in the water may be high during certain times of the day, and the aeration is not so stable because the influent water is not coming as more or less equalized flow. Of course, finally, the quality of treated water suffers, and maybe the plant doesn't even give consistent result any time in a day. What can be the correct approach to design? As you see, we have already identified a revised peak load of 6.5. With this, if we space or calculate the volume of the equalization tank or the collection tank to be almost 12 to 15 hours a day, this should be the right sizing of a school sewage treatment plant collection tank. We really don't have to change anything when it comes to the treatment process itself, but by changing the volume of the collection tank, we are stabilizing the process and the treatment. What do we understand from here is that peak factor must be based on the building type, the users, and the behavior of the users. We use the school as an example, and we worked with a revised or corrected peak flow or a peak factor, and we determined the collection time to be around 12 to 15 hours of holding capacity, not enter into wrong assumptions with peak factors where the entire sewage treatment plant can suffer because of wrong design considerations. Now, with this, I'm sure you agree that collection tank is an integral part of treatment. It is not just for holding the water and transferring the water into the aeration tank. Thank you very much.